Hi, MC Schools TV. Welcome back. My name is Mrs. Rogers, first grade teacher at Carver Elementary. Today, we're going to be looking at two-dimensional shapes and creating new shapes. Our objective today reads, I can name and count shapes as part of a whole, recognizing relative sizes of the parts. Let's look at some of the shapes that I have here for us today. We have a yellow hexagon, we have a green triangle, an orange square, a red trapezoid, a blue parallelogram, also known as a rhombus, and a tan rhombus. Again, as we look at these shapes, these are two-dimensional shapes, and these shapes are flat shapes. Now, before we begin working math problems, I want us to review our tens and ones. I have a cup here, and I have some pennies. We know that the value of a penny is 1 cent. I want you to listen carefully as I drop some pennies into my cup. We're going to count the number of pennies that are in our cup, as well as the value of the amount of coins in the cup. Let's try it. Listen carefully. How many coins are in my cup? Let's find out. 1, 2, 3, 4. Did you guess 4? Good job. Remember, our pennies are worth 1 cent. So, how much money did I have in my cup? Very good. I had 4 cents. Let's try another one. Listen carefully. How many coins are in my cup? 6? Let's find out. 1, 2, 3, 4, 5, and 6. Great job. Kiss your brain. Now, if we had 6 coins in my cup and pennies are worth 1 cent, how much did we have in our cup? What was the value of the amount of coins in our cup? That's right. We had 6 cents in our cup. Now, let's switch to another coin. This is a dime. Dimes are worth, that's right, 10 cents. So, listen again for the amount of coins that is dropped into my cup, and then we'll decide what the value of the amount of coins is in the cup. Listen carefully. How many coins are in my cup? Let's count together. 1, 2, 3, 4, 5, 6, 7. There were 7 coins. Did you know there were 7 coins? Of course you did. Now, let's count by tens to count the value of our coins. Count with me. 10, 20, 30, 40, 50, 60, 70. The value of coins in our cup was 70 cents. Let's try another one. How many coins are in my cup? Let's count together. 1, 2, 3, 4, and 5. There are 5 coins in my cup. Now, again, when we count dimes, we look at the value of the coin, and this coin is worth 10 cents, so we're going to count by 10. Count with me. 10, 20, 30, 40, 50. Our dimes in my cup are worth 50 cents. Great job. Now, I want you to grab some paper. Hurry. Grab some paper and a pencil and let's work some math problems. Before we left school, we knew that we had partners of 10. And we're going to look at some addition problems where we can make a 10. Let's start with our first problem, 9 plus 5. In order to solve this problem, an easy way for us to solve is to break apart our smaller number. When thinking of breaking apart our number, we think of that number as the whole, yet we look at the 9 and we determine 9 and what comes together to make a 10. Good job. 9 and 1 makes a 10. Now let's only focus with our 5. 1 and what makes 5? Very good. 1 and 4 makes 5. We're going to circle the 9 and 1 to show that is our 10. And then we have to add back up the 4. 10 plus 4 is 14. Therefore, 9 plus 5 is also 14. Let's try another one. 8 plus 5. Again, we break apart our smaller number. That's right. This time we look at the number 8 and we think 8 and what makes a 10? You got it, 8 and 2. Now focus again only on the 5. 2 and what makes 5? Very good. 2 and 3 makes 5. Our next step is to make a 10. And then we add back up our 3. 10 plus 3 is 13. Therefore, 8 plus 5 is also 13. Kiss your brain if you knew that. Our next one we have is 7 plus 5. We're going to break apart again our smaller number, which is the 5. Now we look at 7 and its partner that would make a 10. Its partner is the number 3. 3 and what makes 5? That's right, 2. We circle the 7 and 3 because that's our 10. Plus 2 is 12. Keep going. You're doing great. 9 plus 3. We're going to break apart our smaller number, which is, that's right, 3. Then we're going to find what can make a 10. 9 and 1. Very good. 1 and 2 makes 3. We're going to circle 9 and 1 because that's our 10. Plus 2 is 12. Therefore, Therefore, 9 plus 3 is also 12. 2 more, you're almost there. Now we have 8 plus 7. We're going to break apart our 7. This time we're using 8. 8 and, that's right, 2 makes 10. 2 and what makes 7? Don't forget, if you're unsure, you can always count on. 2 and 5 makes 7. We're going to circle our 10. We're going to add back up our 5. 10 plus 5 is 15. Therefore, 8 plus 7 is also 15. And our last one, we have 7 plus 4. We're going to break apart our 4. Using 7, we need to make a partner of 10. 7 and 3 makes 10. 3 and 1 makes 4. We're going to group the 7 and 3 that made our 10, plus 1 equals 11. Therefore, 7 plus 4 is also 11. Great job. Let's keep going. Okay, now let's look at this shape. What are some shapes that you see here in this larger shape? Good job. I see triangles. What else do you see? That's right, a rhombus and a square. Very good. And how many pieces do we see? Let's count them all together. 1, 2, 3, 4, 5, 6, 7. These shapes placed in this order is called a tangram. A tangram is made up of 7 shapes that are not the same sizes that all come together to make other shapes. Let's look at some of these shapes that we created with tangram pieces. Look at our first shape. Our first shape we have, our larger shape that is a triangle. Our smaller shapes that are inside of that triangle are what? That's right, they're also triangles. Let's look at this shape. This shape is a square. This shape was made by using 2 triangles. Okay? Well, let's look at these shapes. Do these shapes have equal parts? No, they don't. This shape is a square, and the other shape is a triangle. Those shapes are not the same. Let's look at this shape. This shape is a triangle, but are the parts equal, meaning that they're the same size? No, they're not. 2 of the triangles are the same size, but the other shape is a rhombus. So these do not have equal parts. Let's look at another shape. This shape is a hexagon. What do you know about this shape? What are its attributes? Be reminded that the attributes are things to describe the shape. We know this shape has 6 sides and 6 corners. What other shapes can we use to make this shape using equal parts? Let's try some. Here's some shapes that we've made. Let's look at the first shape. Does this shape have equal parts? Yes, it does. We see here that the triangles are both the same size. What about this shape? No, that shape does not have equal parts. It has many parts that makes a square, but it does not have equal parts within the square. Let's look at our next shape. Yes, it does. It does have equal parts, and its parts are made with what shape? Good job. It's made with a triangle. Our next shape is a triangle. Does it have equal parts? No, it does not. This shape is made up of triangles, rhombus, and a square. What about our next shape? No, it does not have equal parts either. This shape is made using a square and a triangle. Let's look at our next shape. Yes, that's a triangle. Does it have equal parts? Absolutely, good job. And our next shape we have, does this shape have equal parts? No, it does not. There are 3 parts, but the shape has 2 triangles and a square. Those shapes are not the same. Now, let's look at that hexagon. Now that we've looked at shapes that have equal parts, is the hexagon here made of equal parts? Well, look at this hexagon. Let's count those parts. 1, 2, 3, 4, 5, 6, 7, 8. Looking at that hexagon, some parts are larger than the others. So, we can determine that this shape did not have equal parts. It was not made of equal parts. Let's look at this one. Good job. This shape was created using 2 trapezoids. So it is made of equal parts. Let's look at our next shape. Is that shape made of equal parts? Remember, equal means that the shapes need to be the same. No, it's not. This shape is made of using trapezoids and triangles. Those shapes are not the same. And let's look at our next shape, which is a hexagon, and it's made up of triangles. Good job. That shape is made up of equal parts. And our last shape, very good. The hexagon is made up of equal parts using 3 rhombus. Good job. So, to review, what does it mean when we say a shape has equal parts? Very good. Equal parts means that the shape has parts that are the same. And I want you to think about, while you're home, how is this the same, or how is it different from how we've learned equal in the past? Previously, we've used the word equal when thinking about adding, equal to. Well, we know that equal means that something is the same, and just like we add, both sides need to be the same, and in shapes, the shapes also need to be the same. I hope you've enjoyed my lesson today. I look forward to seeing you again. Bye-bye.